Hey there! Turn on your speakers. Do you have finals week coming up? Projects due? Homeworks are piling up? Are you freaking out that you're getting boxed in with deadlines? Here's an idea. Get help. Think Geek Exams. Find us on Facebook, Twitter, or YouTube.
So this is the first problem in the fifth homework of statics, and we see that there are three anchors in the ceiling, A, B, C, and it's the points A, B, C are at different locations with different coordinates, and basically the coordinates are not given, but they are their distances. The coordinates are given, the dimensions are given from the origin using these lines, and also there's a point D at which the cables are tied, and there's a 917-pound weight connected to D. So let's get these points out of the way. A equals to, in the x direction it is 12 feet away. In the y direction it's actually negative 12, and in the z direction it's actually on the plane. So there you go. So it's 0. And B is going to be B is negative 4 feet, and it is in the x direction negative 3 in the y, and it is also on the xy plane, so z is 0. Okay, now C is negative 4 plus 6 and 0. So they're all in the xy plane, and D is actually, the xy is 0, but negative 12 with the, okay, so 0, 0, negative 12. So if you drew the free body diagram, there would be forces in the direction dA, dB, and dC. So let's get those directions out of the way. dA is A minus D, dB is B minus D, and dC is C minus D. Okay, next we need the unit directions. UDA is dA divided by norm of dA, and same thing with dB and dC. dB is dB over norm dB, and dC is the same. dC is dC over norm dC. So now we have the three directions of the forces, and we need to find out what the TAD, BD, and TCD are. So what we're going to do is we're going to form a U matrix with so I need to actually turn these into column matrices. That might actually help. Column matrices. Okay. Now that we have them as column matrices, let me make sure they are UDA. Oh, that didn't work. Yeah, this is better. So now they should all be column matrices. Okay, now we're ready. So I'm going to form column by column. So each a matrix, a 3x3 matrix, with each column being a unit vector. So U, DA, U, DB, and U, DC, forming a matrix like so. Okay, so now that we have the unit vector, I am gonna create the T. Actually, let's make sure that U has an inverse, and it does, which is good. So now we can make the weight vector. So the weight vector is 917 times 0, 0, minus 1. And so T equals to U to the power minus 1 times, let's put this thing in a parenthesis just so, times minus W. The minus W is the resulting force of all the three forces, and that should give me the right answer. Okay, so this is going to be TAD, which is 397.0726. Next one is 165.5694, and the last one is 624.0694. And let's see if we got the right answers, and they're correct. All right, thank you. See you next time.
Think Geek Exams. Our agents have Masters of Engineering degrees from MIT, Stanford, Georgia Tech, Caltech. We give you solutions to mathematics, physics, computing, and engineering. Find us on Facebook, Twitter, or YouTube.